Example 5. We have to form a PDE by eliminating the arbitrary constant. 2z is equal to x raised to the power of 2 over a raised to the power of 2 plus y raised to the power of 2 over b raised to the power of 2. I'm going to form a PDE by taking away the arbitrary constant. We all know that we have how many arbitrary constants we have in this relation. We have a and b. So it means we are going to differentiate twice, partially with respect to s, differentiating partially with respect to what? Y as well. So solution to this, two z is equal to x square all over what? A square plus y square all over what? B square. Differentiating partially, or differentiating equation 1 partially, differentiating partially with respect to x in equation 1. Let me label this one as equation 1. So it means if I differentiate z with respect to s, I'm going to have the z all over what? The x. I have 2 here as well. I'm going to have what? 2 times this. So I will have, if I differentiate 2z, I'm going to have 2z. I'm going to have 2 z all over what? The s, because I'm differentiating with respect to x. And I have 2 here. So 2 is going to multiply this. Is equal to x square all over a square. You can see that I can use a quotient rule to solve this. A quotient rule, if I have x square all over a square, I'm going to let this one to be v, this one to be what? U. The numerator to be u, while the denominator to be what? V. I'm going to say v du all over ds minus u dv all over ds all over v square. So our v is what? A square. I'm going to have a square. Then I'm going to differentiate the numerator, which is what? U with respect to x. If I differentiate the numerator with respect to s square. If I differentiate s square, I'm going to have 2x. Minus, I'm going to take u. What's my u? My u is what? S square. Then I'm going to differentiate what? I'm going to differentiate v. dv over ds. Our v is what? A square. I'm going to differentiate this denominator with respect to what? With respect to x. You can see that our s is not in e raised to the power of 2. It's going to be constant. And if I differentiate constant, I'm going to have 0. So here will be 0. All over v. V is what? A raised to the power of 2. Then v square. A raised to the power of 2 square. So what am I going to have here? I'm going to have this one is going to a square times 2x. I'm going to have 2a square x all over what? A square dot a square. Because a square raised to the power of a square is going to give me this. Easily I can cancel this one. I can cancel the common terms out. So I'll be left with what? 2s all over what? A square. So it means 2 the z all over the s is what? Is going to give me what? 2as all over what? A square. So remember that our notation that whenever we have the z over the s, it implies what? P. So I'm going to have 2p is equal to what? 2x all over what? A square. I can label this one equation 2. So the next is what? To differentiate equation 1 partially with respect to y. Differentiating equation 1. Differentiating partially with respect. So what am I going to have if I differentiate partially with respect to y in equation 1? It means I have 2z. So if I'm differentiating with respect to what? I'm differentiating z. I'm going to have the z over what? The y. So I'm going to have the z over what? The y. Which is going to give me, if I differentiate x square, I have x square here. Remember, plus y square over b square. What do I have there? Y, I'm differentiating with respect to x. I've not considered this place. If I differentiate this one with respect to x, I'm going to have 0. That is plus 0. I have plus 0 here. Plus 0. Please give me this. So what am I going to have in next? If I differentiate x square with, I'm differentiating this with respect to y. You can see that there's no y terms in this numerator and denominator. So I'm going to have 0 plus. So I'm going to differentiate this one with respect to what? With respect to y. So I'm going to use this same equation, this same formula as well. I'm going to take b square. I'm going to take v. So our v is what? B square. I'm going to differentiate u with respect to what? Numerator with respect to what? With respect to y, I'm going to have 2y. Then minus, I'm going to have u. What is my u? Y raised to the power of 2. So I'm going to differentiate my denominator with respect to y, which is 0, because y is not in that denominator and it's constant. Over v square, that is b square into 2. So I'm going to have, if I use b square to open the bracket, 0 is nothing. I'm going to have 2b square y all over what? B square dot b square. B square is the power of 2, that is b is the power of 4. B square is common here. I can cancel it out. So I'm going to have 2y all over what? B square. So remember that our notation, the z all over the y is always q. The z all over the y is q. I'm going to have 2q is equal to what? 2y all over what? B square. I can label this one as equation 3. So what is my next step? Give you relation. You can say that I want to eliminate what? A and B, a square and b square. So if I consider equation 2, I can make a square as subject of formula. So when I get what is the subject formula of a square, I can input it to here, and as well b square as the subject of formula. So what am I going to have? So in equation 2, I have 2p is equal to 2x all over what? A square. If I cross multiply, I'm going to have 2p a square is equal to what? 2x. I want to make what? A square subject of formula. I'm going to have divided by what? 2p. Divided by what? 2p. So 2p is going to cancel 2p. I've been left with what? A raised to the power of 2 is equal to what? 2x all over what? 2p. Remember that 2 is here, 2 is here. I'm going to left with what? X over p, x all over p. So it means our a square is what? X over p. I can label this one as equation 4. Then in equation 3, make a make b square as a subject of formula. Then the equation will become 2q is equal to 2y all over b square. If I cross multiply, I'm going to have 2q b square is equal to 2y. And I want to make b square as a subject of formula. So I'm going to have divided by what? 2q all over what? 2q. So 2q is going to cancel. Then I'm going to have b square as, I'm going to have b square is equal to what? 2 is going to cancel here. Y all over q. So it means our b is what? Our b is what? Y all over what? Our b is what? B square is equal to what? Y over q. So I can now substitute equation 4 and equation 5 into equation 1. Then the equation becomes, then the equation becomes, so we are substituting this equation 1, equation 4 and 5 into this equation 1. The reason why we are doing that because we have gotten a square, we have made a square subject of formula as s over p. So it means we don't want to have the arbitrary constant. We have to take a square to replace what? This, and b square to replace this. Since they are what? The a and b are what? They are the arbitrary constants. So equation 2z is equal to what? S square all over what? A square. Then plus y square all over what? B square. Remember that this is 2z. S square all over what? A square. It means whenever I see what? A square, I'm going to put what? S over p. So it means I'm going to have S square divided by what? S all over p. If I divide this one by s over, I'm going to have p over x. P all over x plus y square divided by what? B square. What's our b square? Our b square is y over q. Y over q, then y all over what? Q. So what am I going to have next? What is my a square here? A square is s over p. It's s over p. If I change it, I'm going to have times. If I change this one as well, I'm going to have what? As well. I'm going to have q times x. Q all over what? Y. X is common here. S is common. I'm going to have x. Y here 1. Y here 1. So then my equation will become 2z is equal to x times p. X times p, we have sp here, sp plus what? Y times q, then yq, which is the required what? Which is the required PDE? Which is the required PDE? So it means we have what? We have eliminated the arbitrary constants, and our answer for this is what? 2z is equal to sp plus yq, which is the what? Which is the required PDE. It means we have solved the relation given to us, then we have formed another what? PDE, which is our answer is what? 2z is equal to sp plus yq. You can say that our required PDE, our new equation become 2z is equal to sp plus yq. There is no what? There is no an arbitrary constant. Any arbitrary constant is not what? Is not shown in the equation. It means what? We have eliminated the what? Arbitrary constants. I hope you find it interesting. Thanks for watching, and don't forget to share it to others.